The Hawker Siddeley Harrier, known colloquially as the Harrier Jump Jet, was developed in the 1960s and formed the first generation of the Harrier series of aircraft. It was the first operational close support and reconnaissance fighter aircraft with vertical short takeoff and landing capabilities and the only truly successful VSTOL design of the many that arose in that era. The Harrier was produced directly from the Hawker Siddeley Kestrel prototypes following the cancellation of a more advanced supersonic aircraft, the Hawker Siddeley P.1154. The British Royal Air Force ordered the Harrier GR.1 and GR.3 variants in the late 1960s. It was exported to the United States as the AV-8A, for use by the U.S. Marine Corps, in the 1970s. The RAF positioned the bulk of their Harriers in West Germany to defend against a potential invasion of Western Europe by the Soviet Union. The unique abilities of the Harrier allowed the RAF to disperse their forces away from vulnerable air bases. The USMC used their Harriers primarily for close air support, operating from amphibious assault ships, and, if needed, forward operating bases. Harrier squadrons saw several deployments overseas. The Harrier's ability to operate with minimal ground facilities and very short runways allowed it to be used at locations unavailable to other fixed-wing aircraft. The Harrier received criticism for having a high accident rate and for a time-consuming maintenance process. In the 1970s, the British Aerospace Sea Harrier was developed from the Harrier for use by the Royal Navy on Invincible-class aircraft carriers. The Sea Harrier and the Harrier fought in the 1982 Falklands War, in which the aircraft proved to be crucial and versatile. The RNC Harriers provided fixed-wing air defence while the RAF Harriers focused on ground attack missions in support of the advancing British land force. The Harrier was also extensively redesigned as the AV-8B Harrier II and British Aerospace Harrier II by the team of McDonnell Douglas and British Aerospace. The innovative Harrier family and its Rolls-Royce Pegasus engines with thrust vectoring nozzles have generated long-term interest in VSTOL aircraft. Similar VSTOL operational aircraft include the contemporary Soviet Yakovlev Yak-38. A VSTOL variant of the Lockheed Martin F-35 Lightning II is currently under development. Development, origins. The Harrier's design was derived from the Hawker Pages 1127. Prior to developing the Pages 1127 Hawker aircraft had been working on a replacement for the Hawker Hunter, the Hawker Pages 1121. The Pages 1121 was cancelled after the release of the British government's 1957 Defence White Paper, which advocated a policy shift away from manned aircraft and towards missiles. This policy resulted in the termination of the majority of aircraft development projects then underway for the British military. Hawker sought to quickly move on to a new project and became interested in vertical takeoff landing aircraft, which did not need runways. According to Air Chief Marshal Sir Patrick Hine, this interest may have been stimulated by the presence of Air Staff Requirement 345, which sought a VSTOL ground attack fighter for the Royal Air Force. Design work on the Pages 1127 was formally started in 1957 by Sir Sidney Cam, Ralph Hooper of Hawker Aircraft and Stanley Hooker of the Bristol Engine Company. The close cooperation between Hawker, the airframe company, and Bristol, the engine company, was viewed by project engineer Gordon Lewis as one of the key factors that allowed the development of the Harrier to continue in spite of technical obstacles and political setbacks. Rather than using rotors or a direct jet thrust, the Pages 1127 had an innovative vectored thrust turbofan engine, the Pegasus. The Pegasus I was rated at 9,000 pounds of thrust and first ran in September 1959. A contract for 2 development prototypes was signed in June 1960 and the first flight followed in October 1960. Of the 6 prototypes built, 3 crashed, including one during an air display at the 1963 Paris Air Show. Tripartite evaluation. In 1961 the United Kingdom, United States and West Germany jointly agreed to purchase 9 aircraft developed from the Pages 1127, for the evaluation of the performance and potential of VSTOL aircraft. These aircraft were built by Hawker Siddeley and were designated Kestrel FGA-1 by the UK. The Kestrel was strictly an evaluation aircraft, and to save money the Pegasus 5 engine was not fully developed as intended, only having 15,000 pounds of thrust instead of the projected 18,200 pounds. The Tripartite evaluation squadron numbered 10 pilots, 4 each from the UK and US and 2 from West Germany. The Kestrel's first flight took place on March 7, 1964. A total of 960 sorties had been made during the trials, including 1,366 takeoffs and landings, by the end of evaluations in November 1965. 1 aircraft was destroyed in an accident and 6 others were transferred to the United States, assigned the U.S. designation 156A Kestrel, and underwent further testing. The 2 remaining British-based Kestrels were assigned for further trials and experimentation at RAE Bedford, with one being modified to use the uprated Pegasus 6 engine. Pages 1154. At the time of the development of the Pages 1127, Hawker and Bristol had also undertaken considerable development work on a supersonic version, the Hawker Siddeley Pages 1154, to meet a North Atlantic Treaty Organization requirement issued for such an aircraft. The design used a single Bristol Siddeley BS-100 engine with 4 swiveling nozzles, in a fashion similar to the Pages 1127, and required the use of plenum chamber burning to achieve supersonic speeds. The Pages 1154 won the competition to meet the requirement against stern competition from other aircraft manufacturers such as Dassault Aviation's Mirage IIV. The French government did not accept the decision and withdrew. The NATO requirement was cancelled shortly after in 1965. The Royal Air Force and the Royal Navy planned to develop and introduce the supersonic Pages 1154 independently of the cancelled NATO requirement. This ambition was complicated by the conflicting requirements between the 2 services. While the RAF wanted a low-level supersonic strike aircraft, the Navy sought a twin-engined air defense fighter. Following the election of the Labour government of 1964, the Pages 1154 was cancelled, as the Royal Navy had already begun procurement of the McDonnell Douglas Phantom II, and the RAF placed a greater importance on the BACTS-A2's ongoing development. Work continued on elements of the project, such as a supersonic PCB-equipped Pegasus engine, with the intention of developing a future Harrier variant for the decades following cancellation. Production. Following the collapse of the Pages 1154's development, the RAF began considering a simple upgrade of the existing subsonic Kestrel and issued Requirement AS-384 for a VSTOL ground attack jet. Hawker Siddeley received an order for 6 pre-production aircraft in 1965, designated Pages 1127, of which the first made its maiden flight on August 31, 1966. An order for 60 production aircraft, designated as Harrier GR.1, was received in early 1967. The aircraft was named for the Harrier, a small bird of prey capable of hovering. The Harrier GR.1 made its first flight on December 28, 1967. It officially entered service with the RAF on April 18, 1969, when the Harrier conversion unit at RAF Wittering received its first aircraft. The aircraft were built in 2 factories, one in Kingston upon Thames, southwest London, and the other at Dunsfold Aerodrome, Surrey, and underwent initial testing at Dunsfold. The ski jump technique for launching Harriers from Royal Navy aircraft carriers was extensively trialled at RNAS Yeovilton from 1977. Following these tests, ski jumps were added to the flight decks of all RN carriers from 1979 onwards, in preparation for the new variant for the Navy, the Sea Harrier. In the late 1960s, the British and American governments held talks on producing Harriers in the United States. Hawker Siddeley and McDonnell Douglas formed a partnership in 1969 in preparation for American production, but Congressman Mendel Rivers and the House Appropriations Committee held that it would be cheaper to produce the AV-8A on the pre-existing production lines in the United Kingdom. Hence all AV-8A Harriers were purchased from Hawker Siddeley. Improved Harrier versions with better sensors and more powerful engines were developed in later years. The USMC received 102 AV-8A and 80 AV-8A Harriers between 1971 and 1976. Design overview: the Harrier is typically used as a ground attack aircraft, though its maneuverability also allows it to effectively engage other aircraft at short ranges. The Harrier is powered by a single Pegasus turbofan engine mounted in the fuselage. The engine is fitted with 2 air intakes and 4 vectoring nozzles for directing the thrust generated, 2 for the bypass flow and 2 for the jet exhaust. Several smaller reaction nozzles are also fitted, in the nose, tail and wingtips, for the purpose of balancing during vertical flight. It has 2 landing gear units on the fuselage and 2 outrigger landing gear units, 1 on each wingtip. The Harrier is equipped with 4 wing and 3 fuselage pylons for carrying a variety of weapons and external fuel tanks. The Kestrel and the Harrier were similar in appearance, though approximately 90% of the Kestrel's airframe was redesigned for the Harrier. The Harrier was powered by the more powerful Pegasus 6 engine. New air intakes with auxiliary blow-in doors were added to produce the required airflow at low speed. Its wing was modified to increase area and the landing gear was strengthened. Several hardpoints were installed, 2 under each wing and 1 underneath the fuselage. 2 30mm maiden cannon gun pods could also be fitted to the aircraft's underside. The Harrier was outfitted with updated avionics to replace the basic systems used in the Kestrel. A navigational attack system incorporating an inertial navigation system, originally for the Pages 1154, was installed and information was presented to the pilot by a head-up display and a moving map display. The Harrier's VTOL abilities allowed it to be deployed from very small prepared clearings or helipads as well as normal airfields. It was believed that, in a high-intensity conflict, airbases would be vulnerable and likely to be quickly knocked out. The capability to scatter Harrier squadrons to dozens of small alert pads on the front lines was highly prized by military strategists, and the USMC procured the aircraft because of this ability. Hawker Siddeley noted that STOL operation provided additional benefits over VTOL operation, saving fuel and allowing the aircraft to carry more ordnance. I still don't believe the Harrier. Think of the millions that have been spent on VTO in America and Russia, and quite a bit in Europe, and yet the only vertical takeoff aircraft which you can call a success is the Harrier. When I saw the Harrier hovering and flying backwards under control, I reckoned I'd seen everything. And it's not difficult to fly. Thomas Sopwith. The Harrier, while serving for many decades in various forms, has been criticized on multiple issues. In particular a high accident rate, though Nordine notes that several conventional single-engine strike aircraft like the Douglas A-4 Skyhawk and LTV A-7 Cassetto had worse accident rates. The Los Angeles Times reported in 2003 that the Harrier has amassed the highest major accident rate of any military plane now in service. 45 Marines have died and 148 non-combat accidents. Colonel Lee Bulland of the USMC declared the maintenance of the Harrier to be a challenge. The need to remove the wings before performing most work upon the engine, including engine replacements, meant the Harrier required considerable man-hours in maintenance, more than most aircraft. Bulland noted however that the maintenance difficulties were unavoidable in order to create a VSTOL aircraft. Engine. The Pegasus turbofan jet engine, developed in tandem with the Pages 1127 then the Harrier, was designed specifically for VSTOL maneuvering. Bristol Siddeley developed it from their earlier conventional Orpheus turbofan engine, the main difference being the thrust generated is directed through 4 rotatable nozzles. The engine is equipped for water injection to increase thrust and takeoff performance in hot and high altitude conditions. In normal VSTOL operations the system would be used in landing vertically with a heavy weapons load. The water injection function had originally been added following the input of U.S. Air Force Colonel Bill Chapman, who worked for the Mutual Weapons Development Team. Water injection was necessary in order to generate maximum thrust, if only for a limited time, and was typically used during landing, especially in high ambient temperatures. The aircraft was initially powered by the Pegasus 6 engine, which was replaced by the more powerful Pegasus 11 during the Harrier GR.1 to GR.3 upgrade process. The primary focus throughout the engine's development was on achieving high performance with as little weight as possible, tempered by the amount of funding that was available. Following the Harrier's entry to service, the focus switched to improving reliability and extending engine life. A formal joint-use Euro-UK Pegasus support programme operated for many years and spent a £3 million annual budget to develop engine improvements. Several variants have been released. The latest is the Pegasus 11 Euro 61, which provides 23,800 pound force thrust, more than any previous engine. Controls and handling. The Harrier has been described by pilots as unforgiving. The aircraft is capable of both forward flight, as well as VTOL and STOL maneuvers requiring skills and technical knowledge usually associated with helicopters. Most services demand great aptitude and extensive training for Harrier pilots, as well as experience in piloting both types of aircraft. Trainee pilots are often drawn from highly experienced and skilled helicopter pilots. In addition to normal flight controls, the Harrier has a lever for controlling the direction of the 4 vectoring nozzles. It is viewed by senior RAF officers as a significant design success, that to enable and control the aircraft's vertical flight required only a single lever added in the cockpit. For horizontal flight, the nozzles are directed rearwards by shifting the lever to the forward position. For short or vertical takeoffs and landings, the lever is pulled back to point the nozzles downwards. The Harrier has 2 control elements not found in conventional fixed-wing aircraft, the thrust vector and the reaction control system. The thrust vector refers to the slant of the 4 engine nozzles and can be set between 0 degree and 98 degree. The 90 degree vector is normally deployed for VTOL maneuvering. The reaction control is achieved by manipulating the control stick and is similar in action to the cyclic control of a helicopter. While irrelevant during forward flight mode, these controls are essential during VTOL and STOL maneuvers. The wind direction is a critical factor in VTOL maneuvers. The procedure for vertical takeoff involves facing the aircraft into the wind. The thrust vector is set to 90 degree and the throttle is brought up to maximum, at which point the aircraft leaves the ground. The throttle is trimmed until a hover state is achieved at the desired altitude. The short takeoff procedure involves proceeding with normal takeoff and then applying a thrust vector at a runway speed below normal takeoff speed. Usually the point of application is around 65 knots. For lower takeoff speeds the thrust vector is greater. The reaction control system involves a series of thrusters at key points in the aircraft's fuselage and nose, also the wingtips. Thrust from the engine can be temporarily siphoned to control and correct the aircraft's pitch and roll during vertical flight. Rotating the vectored thrust nozzles into a forward-facing position during normal flight is called vectoring in forward flight, or VIFing. This is a dogfighting tactic, allowing for more sudden braking and higher turn rates. Braking could cause a chasing aircraft to overshoot and present itself as a target for the Harrier it was chasing, a combat technique formally developed by the USMC for the Harrier in the early 1970s. Differences between versions. The 2 largest users of the Harrier were the Royal Air Force and the United States Marine Corps. The exported model of the aircraft operated by the USMC was designated the AV-8A Harrier, which was broadly similar to the RAF's Harrier GR.1. Changes included the removal of all magnesium components, which corroded quickly at sea, and the integration of American radios and identification friend or foe systems. Furthermore, the outer pylons, unlike the RAF aircraft, were designed from delivery to be equipped with self-defense AIM-9 Sidewinder heat-seeking air-to-air missiles. Most of the aviators had been delivered with the more powerful Pegasus engine used in the GR.3 instead of the one used in the earlier GR.1. 2-seat Harriers were operated for training purposes. The body was stretched and a taller tail fin added. The RAF trained in the T2 and T4 versions, while T4N and T8 were training versions the Navy's Sea Harrier, with appropriate fittings. The US and Spain flew the TAV-8A and TAV-8S, respectively. All RAF GR1s and the initial aviators were fitted with the Ferranti FE541 inertial navigation attack suite, but these were replaced in the USMC Harriers by a simpler interface weapon aiming computer to aid quick turnaround between missions. The Martin Baker ejection seats were also replaced by the Stenzel SEU-3A in the American aircraft. The RAF had their GR1 aircraft upgraded to the GR3 standard, which featured improved sensors, a nose-mounted laser tracker, the integration of electronic countermeasure systems and a further upgraded Pegasus Mk103. The USMC upgraded their aviators to the AV-8C configuration. This program involved the installation of ECM equipment and adding a new inertial navigation system to the aircraft's avionics. Substantial changes were the lift improvement devices, to increase VTOL performance. At the same time, several airframe components were restored or replaced to extend the life of the aircraft. Spain's Harriers, designated AV-8S or VA-1 Matador for the single-seater and TAV-8S or VA-1 for the two-seater, were almost identical to USMC Harriers, differing only in the radios fitted. The Royal Navy's Fleet Air Arm operated a substantially modified variant of the Harrier, the British Aerospace Sea Harrier. The Sea Harrier was not intended for ground attack duties and, unlike the standard Harrier, was equipped with radar and Sidewinder missiles for air combat duties and fleet air defense. The Sea Harrier was also fitted with navigational aids for carrier landings, modifications to reduce corrosion and a raised bubble canopy for greater visibility. The aircraft were later equipped to use AIM-120 AMRAAM beyond visual range anti-aircraft missiles and the more advanced Blue Vixen radar for longer-range air-to-air combat, as well as Sea Eagle missiles for conducting anti-ship missions. The McDonnell Douglas Avenue 8B Harrier II is the latest Harrier variant, a second-generation series to replace the first generation of Harrier jets already in service. All the above variants of the Harrier have mainly been retired, with the Harrier II taking their place in the RAF, USMC and FAA. In the 1970s, the United Kingdom considered two options for replacing their existing Harriers, joining McDonnell Douglas and developing the BAE Harrier II, or the independent development of a big-wing Harrier. This proposal would have increased the wing area from 200 to 250 square feet, allowing for significant increases in weapons load and internal fuel reserves. The option of cooperation with MDD was chosen in 1982 over the more risky isolated approach. Operational history: Royal Air Force, the first RAF squadron to be equipped with a Harrier GR.1, No. 1 Squadron, started to convert to the aircraft at RAF Wittering in April 1969. An early demonstration of the Harrier's capabilities was the participation of two aircraft in the Daily Mail transatlantic air race in May 1969, flying between St Pancras Railway Station, London and downtown Manhattan with the use of aerial refueling. The Harrier completed the journey in 6 hours 11 minutes. Two Harrier squadrons were established in 1970 at the RAF's airbase in Wildeen-Rath to be part of its air force in Germany. Another squadron was formed there 2 years later. In 1977, these three squadrons were moved forward to the airbase at GR.1 Courtesloe, closer to the prospective front line in the event of an outbreak of a European war. One of the squadrons was disbanded and its aircraft distributed between the other two. In RAF service, the Harrier was used in close air support, reconnaissance, and other ground attack roles. The flexibility of the Harrier led to a long-term heavy deployment in West Germany as a conventional deterrent and potential strike weapon against Soviet aggression. From camouflaged rough bases, the Harrier was expected to launch attacks on advancing armor columns from East Germany. Harriers were also deployed to bases in Norway and Belize, a former British colony. No. 1 Squadron was specifically earmarked for Norwegian operations in the event of war, operating as part of Allied forces Northern Europe. The Harrier's capabilities were necessary in the Belize deployment, as it was the only RAF combat aircraft capable of safely operating from the airport's short runway. British forces had been stationed in Belize for several years due to tensions over a Guatemalan claim to Belizean territory. The forces were withdrawn in 1993, 2 years after Guatemala recognized the independence of Belize. In the Falklands War in 1982, 10 Harrier GR.3s of No. 1 Squadron operated from the aircraft carrier HMS Hermes. As the RAF Harrier GR.3 had not been designed for naval service, the 10 aircraft had to be rapidly modified prior to the departure of the task force. Special sealants against corrosion were applied and a new deck-based inertial guidance aid was devised to allow the RAF Harrier to land on a carrier as easily as the Sea Harrier. Transponders to guide aircraft back to the carriers during nighttime operations were also installed, along with flares and chaff dispensers. As there was little space on the carriers, 2 requisitioned merchant container ships, the Atlantic Conveyor and Atlantic Causeway, were modified with temporary flight decks and used to carry Harriers and helicopters to the South Atlantic. The Harrier GR.3s focused on providing close air support to the ground forces on the Falklands and attacking Argentine positions. Suppressing enemy artillery was often a high priority. Sea Harriers were also used in the war, primarily conducting fleet air defense and combat air patrols against the threat of attacking Argentine fighters. However, both Sea Harriers and Harrier GR.3s were used in ground attack missions against the main airfield and runway at Stanley. If most of the Sea Harriers had been lost, the GR.3s would have replaced them in air patrol duties, even though the Harrier GR.3 was not designed for air defense operations. As such, the GR.3s quickly had their outboard weapons pylons modified to take air-to-air Sidewinder missiles. From 10 to May 24, 1982, prior to British forces landing in the Falklands, a detachment of 3 GR.3s provided air defence for Ascension Island until 3 F-4 Phantom IIs arrived to take on this responsibility. During the Falklands War, the greatest threats to the Harriers were deemed to be surface-to-air missiles and small arms fire from the ground. In total, 4 Harrier GR.3s and 6 Sea Harriers were lost to ground fire, accidents, or mechanical failure. More than 2,000 Harrier sorties were conducted during the conflict, equivalent to 6 sorties per day per aircraft. Following the Falklands War, British Aerospace explored the Skyhook, a new technique to operate Harriers from smaller ships. Skyhook would have allowed the launching and landing of Harriers from smaller ships by holding the aircraft in mid-air by a crane. Secondary cranes were to hold weapons for rapid rearming. This would potentially have saved fuel and allowed for operations in rougher seas. The system was marketed to foreign customers, and it was speculated that Skyhook could be applied to large submarines such as the Russian Typhoon class, but the system attracted no interest. The first generation of Harriers did not see further combat with the RAF after the Falklands War, although they continued to serve for years afterwards. As a deterrent against further Argentine invasion attempts, No. 1453 Flight RAF was deployed to the Falkland Islands from August 1983 to June 1985. However, the second-generation Harrier IIs saw action in Bosnia, Iraq, and Afghanistan. The first-generation Hawker Siddeley airframes were replaced by the improved Harrier II, which had been developed jointly between McDonnell Douglas and British Aerospace. United States Marine Corps. The United States Marine Corps began showing a significant interest in the aircraft around the time the first RAF Harrier Squadron was established in 1969, and this motivated Hawker Siddeley to further develop the aircraft to encourage a purchase. Although there were concerns in Congress about multiple coinciding projects in the close air support role, the Marine Corps were enthusiastic about the Harrier and managed to overcome efforts to obstruct its procurement. The Avenue 8A entered service with the Marine Corps in 1971, replacing other aircraft in the Marines' attack squadrons. The service became interested in performing shipborne operations with the Harrier. Admiral Elmo Zumwalt promoted the concept of a sea control ship, a 15,000-ton light carrier equipped with Harriers and helicopters, to supplement the larger aircraft carriers of the U.S. Navy. An amphibious assault ship, the USSA Guam, was converted into the interim sea control ship and operated as such between 1971 and 1973 with the purpose of studying the limits and possible obstacles for operating such a vessel. Since then the sea control ship concept has been subject to periodic re-examinations and studies, often in the light of budget cuts and questions over the use of supercarriers. Other exercises were performed to demonstrate the AV-8A's suitability for operating from various amphibious assault ships and aircraft carriers, including a deployment of 14 Harriers aboard USS Franklin D. Roosevelt for 6 months in 1976. The tests showed, amongst other things, that the Harrier was capable of performing in weather where conventional carrier aircraft could not. In support of naval operations, the USMC devised and studied several methods to further integrate the Harrier. One result was Arapaho, a standby system to rapidly convert civilian cargo ships into sea-going platforms for operating and maintaining a handful of Harriers, to be used to augment the number of available ships to deploy upon. When the reactivation of the Iowa-class battleships was under consideration, a radical design for a battleship carrier hybrid emerged that would have replaced the ship's rear turret with a flight deck, complete with a hangar and 2 ski jumps, for operating several Harriers. However, the USMC considered the need for naval gunfire support to be a greater priority than additional platforms for carrier operations, while the cost and delay associated with such elaborate conversions was significant, and the concept was dropped. The Marine's core concept for deploying the Harriers in a land-based expeditionary role focused on aggressive speed. Harrier forward bases and light maintenance facilities were to be set up in under 24 hours on any prospective battle area. The forward bases, containing 1 to 4 aircraft, were to be located 20 miles from the forward edge of battle, while a more established permanent airbase would be located around 50 miles from the FEBA. The close proximity of forward bases allowed for a far greater sortie rate and reduced fuel consumption. The Avenue 8A's abilities in air-to-air combat were tested by the Marine Corps by conducting mock dogfights with McDonnell Douglas F-4 Phantom IIs. These exercises trained pilots to use the vectoring in forward flight capability to outmaneuver their opponents and showed that the Harriers could act as effective air-to-air fighters at close range. The success of Harrier operations countered skepticism of VSTOL aircraft, which had been judged to be expensive failures in the past. Marine Corps officers became convinced of the military advantages of the Harrier and pursued extensive development of the aircraft. Starting in 1979, the USMC began upgrading their aviators to the AV-8C configuration. The work focused mainly on extending useful service lives and improving VTOL performance. The Avenue 8C and the remaining AV-8A Harriers were retired by 1987. These were replaced by the Harrier II, designated as the AV-8B, which was introduced into service in 1985. The performance of the Harrier in USMC service led to calls for the United States Air Force to procure Harrier IIs in addition to the USMC's own plans, but these never resulted in Air Force orders. Since the late 1990s, the AV-8B has been slated to be replaced by the F-35B variant of the Lockheed Martin F-35 Lightning II, a more modern VSTOL jet aircraft. Other operators. Due to the Harrier's unique characteristics, it attracted a large amount of interest from other nations, often as attempts to make their own VSTOL jets were unsuccessful, such as in the cases of the American 15-4 Hummingbird and the German VFW VAK-191B operations by the USMC aboard the USS Nassau in 1981 and by British Harriers and Sea Harriers in the Falklands War proved that the aircraft were highly effective in combat. These operations also demonstrated that Harrier carriers provided a powerful presence at sea without the expense of big deck carriers. Following the display of Harrier operations from small carriers, the navies of Spain and later Thailand bought the Harrier for use as their main carrier-based fixed-wing aircraft. Spain's purchase of Harriers was complicated by long-standing political friction between the British and Spanish governments of the era. Even though the Harriers were manufactured in the UK, they were sold to Spain with the US acting as an intermediary. Since 1976, the Spanish Navy operated the AV-8S Matador from their aircraft carrier DAR copyright Darlo. The aircraft provided both air defense and strike capabilities for the Spanish fleet. Spain later purchased 5 Harriers directly from the British government to replace losses. Hawker Siddeley aggressively marketed the Harrier for export. At one point the company was holding talks with Australia, Brazil, Switzerland, India and Japan. Of these only India became a customer, purchasing the Sea Harrier. At one point China came very close to becoming an operator of the first-generation Harrier. Following an overture by the UK in the early 1970s, when relations with the West were warming, China became interested in the aircraft as it sought to modernise its armed forces. British Prime Minister James Callaghan noted significant hostility from the USSR over the sales bid. The deal was later cancelled by the UK as part of a diplomatic backlash after China invaded Vietnam in 1979. The Spanish Navy, Thai Navy, Royal Air Force, and United States Marine Corps have all retired their first-generation Harriers. Spain sold 7 single-seat and 2 twin-seat Harriers to Thailand in 1998. The Royal Thai Navy's AV-8S Matadors were delivered as part of the air wing deployed on the new light aircraft carrier HTMS Shakri Narubit. The Thai Navy had from the start significant logistical problems keeping the Harriers operational due to a shortage of funds for spare parts and equipment, leaving only a few Harriers serviceable at a time. In 1999, 2 years after being delivered, only one airframe was in airworthy condition. Around 2003, Thailand considered acquiring former Royal Navy Sea Harriers, which were more suitable for maritime operations and better equipped for air defense, to replace their AV-8S Harriers. This investigation did not progress to a purchase. The last first-generation Harriers were retired by Thailand in 2006. Variants: Harrier GR.1, GR.1A, GR.3, single-seat versions for the RAF. The RAF ordered 118 of the GR.1 per Grain 3 series, with the last production aircraft delivery in December 1986. 122 built. AV-8A, AV-8C Harrier, single-seat versions for the U.S. Marine Corps. The USMC ordered 102 AV-8As. The Avenue 8C was an upgrade to the AV-8A 110 built. AV-8S Matadora, export version of the AV-8A Harrier for the Spanish Navy, who designated them as VA-1 Matador 10 built. Harrier T2, T2A, T4, T4A, two-seat training versions for the RAF, with a stretched body and taller tail fin. 25 built. Harrier T4N, T8, T60, two-seat training versions for the Royal Navy and Indian Navy with avionics based on the Sea Harrier. TAV-8A Harrier, two-seat training version for the USMC, powered by a Pegasus Mk103. TAV-8S Matadora, two-seat training version for the Spanish Navy and later sold to the Royal Thai Navy. Operators: A Thailand, Royal Thai Navy; A India, Indian Navy; A Spain, Spanish Navy; A United Kingdom, Royal Air Force, Royal Navy; A United States, United States Marine Corps, aircraft on display. Canada Avenue 8A, 158,966, Canada Aviation and Space Museum, Ottawa, Ontario. Germany, GR.1, XV278, Luftwaffenmuseum der Bundeswehr, Gatow. GR.3, XZ998, Flugausstellung Neo Junior at Hermskiel. Poland, GR.3, XW919, Polish Aviation Museum, Kraków W, Poland. New Zealand, GR.3, XZ129, Ashburton Aviation Museum, Ashburton, New Zealand. United Kingdom, GR.1, XV277, National Museum of Flight, East Fortune. GR.3, XV744, Tangmere Military Aviation Museum, Chichester, West Sussex. XV748, Yorkshire Air Museum, Elvington. XV751, Gatwick Aviation Museum, Surrey. XV752, Bletchley Park, Buckinghamshire. XV779, RAF Wittering. XZ133, Imperial War Museum, Dewford. XZ968, Muckleberg Collection, Norfolk. XZ997, RAF Museum, Hendon. ZD667, Bentwaters Cold War Museum, Suffolk. Mk52 GVTOL, ZA250, Brooklands Museum, Surrey, T2XW269, Air World Aviation Museum Carnarvon, Wales, T4, XW934, Farnborough Air Sciences Trust, Farnborough, Hampshire, United States Avenue 8A, 158,976, Cherry Point MCAS, North Carolina. TAV-8A, 159,381, Oakland Aviation Museum, Oakland, California. AV-8C, 158,387, Flying Leatherneck Aviation Museum, Marine Corps Air Station Miramar, San Diego, California, 158,710, Quonset Air Museum, North Kingstown, Rhode Island. 158,975, National Naval Aviation Museum, NAS Pensacola, Pensacola, Florida, 158,977, Museum of Flight, Seattle, Washington, 159,232, Intrepid Sea, Air and Space Museum, New York City, New York, 159,241, Palmer Air and Space Museum, Tucson, Arizona. Specifications, data from Jane's All the World's Aircraft 1988 to Euro 89, General characteristics, crew, 1, length, 46 feet 10 inches, wingspan, 25 feet 3 in, height, 11 feet 11 in, wing area, 201.1 FTA squared, empty weight, 13,535 pounds, max takeoff weight, 25,200 pounds, power plant, 1 Rolls-Royce Pegasus 103 turbofan with 4 swiveling nozzles, 21,500 pound forces, 4 vertical flight puffer jets use engine bleed air, mounted in the nose, wingtips, and tail. Performance, maximum speed, 730 miles per hour at sea level, combat radius, 230 miles low with 4,400 pounds payload, ferry range, 2,129 miles, endurance, 1 hour 30 minutes from base, service ceiling, 51,200 feet, time to climb to 40,000 feet, 2 minutes 23 s, armament, guns, 2 30mm Aiden cannon pods under the fuselage, hardpoints, 4 underwing and 1 under fuselage pylon stations with a capacity of 5,000 lba and provisions to carry combinations of rockets, 4 Matra rocket pods with 18 SNEB 68mm rockets each, missiles, 2 AIM-9 Sidewinders air-to-air missiles, bombs, a variety of unguided iron bombs, BL-755 cluster bombs or laser-guided bombs, others, 1 reconnaissance pod, 2 drop tanks for extended range loitering time. Popular culture. See also: Aircraft in fiction, Harrier family, aircraft of comparable role, configuration and era, Rockwell XF-V12, Yakovlev Yak-38, references, notes. Citations. Bibliography. Further reading. External links, Harrier history website, Harrier page on globalsecurity.org, Harriers lost in the Falklands, Harrier GR.3 in Beijing Aviation Museum, China, Harrier, world's first fixed-wing VSTOL weapons system, a 1967 article in Flight, Harriers for the United States. 1969 Flight article on the USMC case for the Harrier, V for 2, a 1972 Flight article on the two-seat Harrier T2, in the air, Harrier, a 1973 Flight article on flying the Harrier.